Hey everyone, this lesson will cover Notes 8-1 translation. A transformation is a change in position, shape, or size. So for example, let's say we take this point, let's say this is point A, and we do a transformation to it. Whenever after we've done the transformation, we use this notation. So this is read as A prime, okay? So this is what we call prime notation. So whenever you see something like this is the original or old figure, and this will be the new figure. So in this case, this is the old point, and this is the new point, okay? So I'm saying that here, so the pre-image, which is the original, we call this one the old figure. And then once we apply the transformation, which is what the arrow here means, we call that the image or the new figure. So we have a triangle here. Okay, notice this is A, triangle A, B, C, and we apply a transformation to it. And once we do that transformation, we label this as A prime, B prime, C prime. Okay, now we have 4 different types of transformations. We have a translation or translate, and when you see translate, think that you are going to slide the figure or point. We also have reflection or reflect. Reflect means we are going to flip the figure. Okay, I guess that's an easy way to remember. And rotation, or we rotate a figure. All we do is we turn the figure about. There's an angle of rotation. Okay, and that has to be stated. Dilation, when we dilate a figure, we could either make it grow or make it larger, or we can also shrink it or make it smaller. Okay, you're gonna see this term on the assignment. Okay, so when you see it, just understand what it means. Rigid transformation. This is a transformation that keeps distance and angle measure of the same. So, in other words, this is what this means. It means it's going to be the same size. So it's not going to get larger, it's not going to get smaller, it's going to be the same size when you do the transformation. Okay, the only transformation that changes size is this one here. So dilation. This is the only non-rigid transformation. And translation, okay, translation is a slide. So this one is a transformation that maps points in the same distance, okay, and direction. So all points on the figure are going to move the same distance and in the same direction. Next, I'm going to introduce you to some notation. As you know, in mathematics, we use notation to communicate as best as possible what we mean, okay, without having to use too many words. So arrow notation. So whenever you see this means we are going to take the x and y coordinates, and to the x coordinates, we're going to add or subtract a value of a. So a can be any number. It could be 1, it could be 2, it could be 25. So a is any value. Now, when you see addition here, that means the figure is going to be translated to the right, or we're going to do a slide to the right. But if you see a minus here, instead of x plus a will be x minus a, that means the figure is going to go to the left. That's for the x value. So this is the horizontal transformation. Now, to the y, if you see plus means you're going to move that figure up. If you see minus, you're going to move that figure down. Okay? So let's go over the next few examples. Let's look at example number 1. So let's do part A. So arrow notation is telling us that to take the x and y coordinates, and the x's are going to go to the right 4 units, and the y's are going to go down 3. So all we have to do is we can start with this point here. Let's say point Q. Okay, so point Q, we take each one of the x coordinates. Okay, so this one is gonna go to the right 4. 1, 2, 3, 4, and then down 3. 1, 2, and 3. So this is now point Q. It's not just Q because we did a transformation. So this is Q prime. And then we do the same with point K. So again, 4 units to the right and 3 units down. So 1, 2, 3, 4. 1, 2, and 3. So this is now point K, but it's being transformed, so it's K prime. Okay, and do the same with point E. 1, 2, 3, 4. 1, 2, and 3. So this is now E prime. And then I'm going to connect the points. So as you can see, the triangle didn't get larger, didn't get smaller. It just got translated 4 units to the right and 3 units down. Okay, so just so that you're not confused, I'll just shade this. So you're basically just counting. Okay, so each point has to go the same distance horizontally and vertically, which is what this is saying. And again, this is arrow notation. Okay, which is what I explained here. So let's go over to the next example. So as you can see, the arrow notation is saying to the x values you're going to add 2, and to the y values you're going to subtract 5. Okay, so what I'm going to do here is I'm going to this x value, this is saying add 2 to it. So I'm going to add 2 to negative 3. Okay, and to the 0 value I'm going to subtract 5. So to this one I'm going to subtract 5. And to get the new coordinate for r prime, 2, negative 3 plus 2 is going to give me a negative 1. And 0 minus 5 gives me a negative 5. So these are the coordinates of r prime, which is the same point here, but it's just being translated 2 units to the right and 5 units down. Okay, same thing with q prime. Okay, so this is r, that's r prime, and then let's do q prime. So q prime to this one, again, same thing. I'm going to add 2 to the x coordinate, so plus 2. And to the y coordinate, I'm going to subtract 5. So to this one, minus 5. 4 plus 2 is 6. And then negative 1 minus 5, that's a negative 6. So these are the coordinates of q prime. Okay. The next one is going to be u. And again, we apply the same transformation. So to the x values, we're going to add 2, and to the y values, we're going to subtract 5. So this will be u prime, and the coordinates of u prime are 2 plus 2 is 4, and 2 minus 5, that's a negative 3. So these are the new coordinates of these 3 points with the transformation stated in arrow notation. Okay, so this will be the answer to that problem. Let's go over the next 2 examples. So notice the difference on the on example number 2, part A. This is asking us to write a rule to describe the translation. Okay, so what we have to do is notice that this is the original figure. How do we know? And I know it's hard to see it here, but these points, okay, have the prime symbol, and it's hard to see it, but I hope you can notice it, even though it's barely noticeable. We know that this is the old figure and this is the new figure. Okay, so I'll just label this as old and this is the new. Why? Because this is the one that has the prime symbols. So let's see what happened here. So as you can see, this point went from here, it went 1, 2, it went 2 units to the left, right? And then it went up 1, 2, 3, 4. Since it went 2 units to the left, this will be a minus 2, and 1, 2, 3, 4, 4 units up. And then if you check this point here, okay, this one goes up or goes to the right 1 and 2, okay, and then it goes up 1, 2, 3, 4. So as you can see, 2 to the left, and 4 up also here. And then the last point, this one went 1, 2, 3, 4 up, and left 1 and 2. So we have the same thing. Now to write the rule, I'm going to take the x coordinates. Okay, I'm going to state that here. And what am I going to do to the x values? This is saying left 2, so that means I'm going to subtract. So to the x values, I'm going to subtract 2. And to the y values, this went up 4. So I'm going to add 4 to the y value. So this will be the rule that will tell me what I'm supposed to do this transformation, or what happened in this transformation. Okay, so this is a translation of the x and y values of x minus 2 or left 2 and y plus 4 or up 4. Okay, let's do the last example. So notice on this one we're given points. We're given the coordinates of 2 points. So this is m and m, and this is m prime. So the question is, how do we go from 2 to negative 6 for the x coordinates? Okay, so this transformation is to go from 2 to negative 4. That means you're going to subtract 6. And now let's do the y coordinates. So how do we go from 0 to negative 3? That means we are going to subtract 3 from 0. So then to write the rule, you would say x and y coordinates, and I'm going to the x coordinates, I'm going to subtract 6. So x minus 6. And to the y coordinates, I'm going to say y minus 3. So this is the rule that would help you determine this transformation. Or you can also write it down. You can say left 6 and down 3, which is what this is saying. Left 6, down 3. Okay, I hope that helps. I'll see you next time. I'll see you the next time. Bye-bye.